Welcome you all to this Cryo-EM course. Last class we discussed about that how wave propagates and how we can represent it in a phasor diagram, and we are constantly talking about the single wave. Not only that, I showed you how we can add two waves and what will be their amplitude. Main difference will be the amplitude. Now let us take a look how we can add those wave in a more scientific manner, not like that two waves we are drawing each other and then we are telling that one case if waves are in a different phase, is one wave is in going this direction, one wave is going this direction. So, there is a two different phase and that is going to cancel each other, and the resultant wave will be, amplitude will be very less. And the other way is that if there is a one wave is going this direction, one wave is coming in this direction and other wave is also in a same phase, there will be a higher amplitude, the amplitude will be much bigger. But how do we add those waves? So, as I start at the beginning, I told that I do not want to go through the mathematical details how we can add those waves. Here I will just show you some phasor diagram, and I will just show you that simple addition of couple of waves, and that will really help us in future also when you will deal with that multiple electrons are coming and giving us an image. So, let us start. So, we already discussed these things couple of times. I will start here that okay, there is a two waves can go, right. There is a one wave it is going, and then just consider there is a nearby another wave is going, and then another third wave is also there. So, here you can see when these three waves are going, these three waves propagates in x direction. Again, this is the spatial frequency and this will be the amplitude. Now, here you can see that in this all these three wave, that wave 1, wave 2 and wave 3, they are almost in same amplitude, there is no change in the amplitude and there is not too much phase difference, they are not in a opposite phase, right. And then if we want to draw that resultant wave, what will happen? Resultant wave will be, it will give us a bigger amplitude all the time. So, our amplitude will increase. Now, we will deal with only two waves. So, here there is a one diagram. We can tell that okay, if this wave, that we already discussed this one couple of times, that okay, there is a one wave that is a sin kx, right. Then the second wave is a sin kx plus pi by 3, then x. So, different waves are there, and they are, if they are in phase, if they are not in completely out of phase, so they will merge together and they will give this kind of higher amplitude, right. So, here we have another one that is kx, then pi by 2. So, if we consider that okay, there is a one wave is this one and the other wave is this one. So, as I mentioned, we are going to deal with only two waves, wave 1 and wave 2. So, there is a two wave is there, wave 1 and wave 2. So, you just consider that this is alpha, first wave, and then this is alpha 1. So, that we are talking about this particular angle, whatever angle we are talking. So, alpha 1 and alpha 2 is the phase difference between these wave 1 and wave 2. There is a two wave. So, there is a phase difference between these two waves is alpha 1 and alpha 2, and we have to add those wave. How we can add those wave? We will draw this diagram again. First thing first, I will just draw that blue wave. Blue wave is not that big, so we have to read. So here the blue wave, this is the blue wave and this is the angle alpha. Now if you look at here, the alpha 1, definitely alpha 1 is bigger than alpha. Alpha 1 is bigger than alpha. So what is the difference between the phase between these two wave? The major difference, because the amplitude is almost same. So this is, as I mentioned, that this length, it will be the amplitude of that wave. This is, so both the cases you can see the amplitude is almost same. What is the difference? Difference is the phase. So what is the phase difference between these two wave? So we can consider this is alpha minus alpha. This is the phase difference between these two wave. So now what we can do, we can say that okay, this is the line what I have, the straight line I am drawing, and now what is the difference between this wave phase and this, because this wave also has some phase alpha that we are drawing here. So now we are drawing this, and now what is the difference between wave 1 and wave 2? So wave 1 and wave 2 difference is this one, alpha 1 minus alpha. So I am drawing that wave like that. So here in vector diagram, whenever you will try to add them, these waves, it will be always like that, it will be a continuous. So one wave start point will be this, whatever the end point, the second one we have to start from that, and we have to consider that angle here very carefully. So if there is an angle change, then we cannot get the proper. So this will be alpha 1 minus alpha, if we just consider this one, and this is the alpha. Now you can see there is a two wave. So now we want to add these two vector. So best way to add this one, if we just use the other color. So here this will be my resultant wave. So if I just note that this will be my alpha 1, it will be better to mark this one with a black. So this is my second wave, wave 2. So wave 1 is finished here and wave 2 started from here to here, and this I mentioned, this is the amplitude, and then when that will finish, the resultant wave, it will connect from the first wave end point to second wave, the final point. So you have to add them. So this will be our resultant wave. So here one thing you can see that there is a, in the resultant wave, it has a new angle, phase angle, as well as is value, this total value or amplitude is increased drastically. So here the take home message is that this angle is very important. Even if there is a no change in the amplitude, this angle will play a vital role, and that will help us to add these two vector. This is one example that where we can add these two vector. Now let us take a look some other example, that if there is a in a other situation, how do we add those, vectors. So here I am drawing and giving you a new page. We'll just, so if we just consider that there is a two vectors are there, and two vectors, if as here we have a 4, we will consider that there is a two vectors. One vector, I will just use this blue color here, and another vector is this red one. And both the cases you can, what you can see, both the cases, in the previous case what we notice that there is a two vector, one is going, one wave is going this direction and one wave is going this direction, and they have angle difference and we can add. So this one also we can add it in a same way. So, previous one what we did, we just added like that and then we got the resultant vector here also, but the major difference between these two wave, what we can see here, there is a no phase difference between these two, they are going in a same direction. So, it is something like that if I want to draw that using a sign or so, there is a one wave and the other wave is exact same phase, but their amplitude is different. So, here you can see this is wave 1 and this is wave 2, and here the blue one, you can consider that blue one is wave 2 and the red one is wave 1. When they are coming together, their amplitude will be very big, something like that. So, here also when we want to draw this kind of vector or we want to add this vector, how we can add this vector here. So, first thing first, we have to plot the first vector here, okay. Then it is coming to the second vector. Second vector is the or second wave. So, I am drawing the second one. So, when there is a two waves is attached and I have to connect from the first vector end to the second vector end. So, I have to connect both of them. So, my resultant vector, it will be like that. So, the resultant vector will be adding up this amplitude of both the waves, and the resultant wave, this will be much bigger than any other addition. So, these cases can see a very huge amplitude difference than any other kind of addition. This will really help when we will discuss about the CTF. So, CTF is contrast transfer function. Whenever we are dealing with a microscope, there is a lot of electron beam will converge and diverge, and that will give us an image. So, there contrast transfer function, how this contrast is transferred, that is a very important part. So, that it is going to help us when we will discuss about this. In some cases we will lose the signal, some cases there is a two waves are merging together, but still that information is not visible, and some cases these waves are merging together and information is huge, they are, we are getting a huge amplitude, and that is or intensity, that is we are recording here. And some cases information is there, but it is represented or they are just converging in such a way that we lost that information, or it is going to, or the negative one, that we have to correct during the CTF. So, that is called contrast transfer function. That time this vector addition, it will really help us. So, that is one of the addition I showed you, that is if this is the case, we will get the maximum amplitude. Here we can see that amplitude is maximum here, we will not get this kind of big amplitude in any cases. Now, there will be another possibility. Let us take a look at another possibility. If that is a vector, I already have a vector diagram, that is I told, okay, this is the blue one. What about a wave is going completely a different direction? So, we already discussed about that negative side, that x axis, y axis. So, here wave is going in a negative direction and we want to get the resultant vector. How we can do it? So, here this is the x axis and this is our amplitude. So, amplitude is also different. Now, in this particular case, what we have to do? We have to take this particular wave, and this is the end of the first vector, and from this end we have to start the second vector, and second vector will end here. So, we will get a resultant vector that will be this much. So, in this particular case, you can see when there is a two waves are going completely two different direction, our amplitude will be different. How can we represent that thing? We can represent these things here. If this is our x and y axis, one wave, that blue wave this is the amplitude, and the red wave, this is the negative amplitude. So, you can see that amplitude. So, here if the amplitude is 1, here may be 0.08, but negative, this negative amplitude, say another wave it is going. So, in this particular case, if we want to add these two wave, what will happen? This amplitude, this blue wave amplitude is much bigger, it is 0.1, and the other hand the red wave, the amplitude is much lesser, it is minus 0.08, right. So, definitely if there is a superposition of these two wave, and if we just try to add their amplitude, because they are in a completely opposite phase, their overall amplitude it will decrease, and that is we can see it here, that if we look at this one, we can see that amplitude is decreased drastically. So, if waves are going in a opposite direction and they converge, so it can affect the amplitude also, which is affecting here. We can see amplitude is reduced. Okay. There is some other possibilities are also there, that okay, if there is a different angle between two waves, what is going to happen? That okay, there is a two waves that it has a different angle. So, let us take a look that okay. So, if we have something so we have two wave. So, we can consider that one wave, we have this one, that let us draw it blue, and blue wave angle is alpha, and the other one you just consider that wave has a completely different angle, something like this red one. Okay. So, it has some, you just consider that it will be some 2 pi by 3. Now, there is a two wave and we have to add these two wave. So, this is my wave number 1 and this is my wave number 2, and wave number 1 and wave number 2 we have to add it. So, we will just use here to draw that diagram how. So, first wave, now we know how to add those vectors, because we already discussed these things multiple times, that okay, how we can add that. So, I already showed you that two vectors how we can add. So, when there is a different angle, that alpha, if this is a certain angle, then rest of the angle you will add it here and then you will draw the resultant one. So, same way we will do it here. We have the first wave, the amplitude, there will be no difference of the amplitude, this will be alpha and this will be the omega 1. Now, if we want to draw the second one, you have to draw it like that. First, let us do it in a little bit simpler way. So, we will consider this one like that, the blue one, I will draw it like that. Okay. Now, I will take the second wave. Second wave, I know that difference. What is the difference here? If we know the difference, okay. So, if it is some angle, so we can draw that one. So, if we okay, let us do it in this way, it will be much easier to explain when you will consider that if alpha, because I draw this one in a straight line here. So, just consider that alpha equals to 0 here, we are considering. So, if alpha equals to 0 here, we can represent this wave like that. Okay, it will come straight here. Okay. So, this will be easier for you to understand, that is the reason I am just representing this entire thing. So, here this will be the wave 1 where alpha equals to 0. So, it will be something like that, wave 1 will be a sine kx, where this red one will be sine 2, it will be a sine kx plus 3 pi by 2. Okay. So, now we initially consider that okay, alpha some angle is there, and then later we consider alpha equals to 0, because it will help us to represent this entire thing in the left hand side. Otherwise, you know, if I just draw this vector addition, it will be very complicated for you. That is the reason we consider that okay, alpha equals to 0. Now, the next one I have to draw, because first vector I already finished here. This is my first vector, this is my, so here equals to a sine kx, and this is the amplitude, total amplitude. Now, what is the direction? From this one we have to consider the angle, right? We have to consider this angle. So, angle will be 2 pi by 3, this is the difference, phase difference. So, here I am drawing that phase difference. So, here phase difference between these two wave, blue wave and the red wave. So, 2 pi by 3, from 0 I am drawing that 2 pi by 3, and this is the position of my second wave. So, second wave means wave 2 equals to a sine kx by 2 pi by 3. Now, I want to get the resultant wave. Again, we all know that how we can get the resultant wave. It will be joining of the end point of the first vector and the second vector. So, start point and the end point addition. So, here we have to add both of them. So, if we just add the start point and the end point here, what we will get here? This will be our resultant vector, and resultant vector will be r. In this particular case, one important part we all should remember that okay, so in this particular case we can see that overall this size of this particular vector, the resultant vector and the blue wave, the almost same their amplitude. So, there are two waves addition is there, but just because of this particular angle, after this addition there is not much gain or loss of amplitude. So far we gain 4 different conditions. Let me quickly draw that. So, in one single page, so that will be easier to understand. So, first one what we got? First one we got this one, that okay, there is a blue wave, and then we are getting a red wave, and then we are getting the resultant wave. This is our resultant wave, and this is wave 1 and this is wave 2, right. Then we are coming to the second one. Second one what I did? I did, this is my first wave and then my second wave, and then we are getting a amplitude very high. So, this kind of vector addition, this is the start point and this is the end point, and when you are getting this kind of vector addition, if I just consider this is R1, this is R2, and then we consider the third one also. Third one is the opposite, if you recall properly. So, this is the red blue wave, and then this is the red wave, and we will get the resultant wave this one. So, resultant wave will be R3. Final one we did it like that. This is our blue wave, then our red wave, and then we are getting our resultant wave. So, in this case I told they are amplitude wise they are almost same. So, now if we just consider, so this will be our wave R4. So, maximum amplitude will get it here, that as I told R2 will be much higher, then we will get this one R1, and then we will get R4, and then so when they are completely opposite, many cases we will lose our signal, and some cases even two waves are converging together, they are merging together, but still we are not gain any extra intensity, or we are not lose any amplitude intensity. That is happening in this particular case. So, there are two situations, that is the situation 1 and situation 2 will gain our amplitude will be higher, in the other case we will lose it. So, this is not very good, and this is almost neutral, nothing new we can gain from this one. So, now we have to think that how it is going to help our imaging, why we are worried about all of these things so much. Let us take a little bit complicated stage one more, and then we will go more about that why it is so important. Okay. So, previously I did this drawing couple of times. Let me go through that superposition of 3 harmonic wave. So, I did these things couple of times. So, first wave I am just using this blue, okay. It is going in this direction. Then the second one, those are the harmonic wave, okay. Then we will just use the black color. I just finished this drawing. So, here then again I will just consider any other pink. So, here also going like that. So, in those cases if I want to draw the amplitude, there is a 3 waves addition is there. If we want to add it like that, one is black is or blue. If I just consider this is the blue wave. So, I am drawing that blue wave here, this is the blue, and then red, there is a not too much angle difference between them. So, this is the third one, and third one it will come the black. So, third one also I have to draw like that, and then we can add all of them. So, in those cases your amplitude will be much higher. Okay. So, but at the initial stage there will be not too much difference, but if you will keep going on like that, after a certain time you can see that there are some changes, and they are completely in opposite phase. If we will keep going on in this way, they are completely opposite phase and they will normalize each other. So, in this particular case that okay, we have a 4 wave, then I want to add those things. How we can add here? I want to show it here that okay, there is a vector addition, I want to do it. So, first wave, I will draw that first wave, that is the blue one, small angle, and then the red. So, first I have to draw that line, and then what is the difference between these two. So, this small angle difference I am drawing. Okay. Then black. So, from red we will just continue. So, then this black it will come into the picture. Okay. This is the angle difference between the first wave here, the blue and red wave, then red and black. Then when this is done, then the pink it is coming. So, black, if we just draw the dotted line, so this will be my final one. So, now the resultant wave it will be these two. So, this will be my resultant wave. So, you can see after addition of this 4 wave, the first phase the amplitude is very high. But as I mentioned that if you continue in this direction like that, if you keep going on in this direction, after a certain time you can see that there is a phase difference between this wave and this wave. They will be not uniform all the time. So, and that is going to affect our amplitude in the later stage, that we are going to discuss in the next class. And thank you all for your attention. In the next class we will discuss that okay, if there is a little bit phase difference, how it is going to affect and how we will get a resultant wave, and then finally we will discuss about how we can convert those waves to image. Thank you all for your attention.